This is chapter 9, the very last chapter for semester 1, wrapping up the functions topics. We're going to look at arithmetic and geometric sequences. We're going to look at finding the nth term. So what is a sequence or a series? What does finding the nth term mean? We'll look at those things today. But I'm going to start with a little puzzle, and you'll want to pause this and guess these on your own. But the first one is you have a list of letters, and you're supposed to figure out what the next terms are. Now, a term is an item, and a sequence is a list. So we have a list, O, comma, T, comma, T, comma, F, comma, and then you're going to put the terms into each of these in the sequence. So what in the world could this be? Well, I'll give you one clue for this one, a second clue for this one, but I'm not going to give you a third and a fourth clue to get you this, this, and this. Those are the first letters of the words of the numbers 1, 2, 3, 4, 5. Number 2 and 3, I'll give you 2 hints. 2 has to do with the year, and 3 has to do with literature. 4 is a science question, and it's probably my favorite. The sequence H, I, J, K, L, M, N, O, and you're trying to find out what word this sequence represents for these letters, H all the way to O. What word is it? All right, so a sequence is a function that gives you terms, and the domain are all the natural numbers. So what's a little different is we're not dealing with fractional values. This is all going to be 1, then 2, then 3, and so on. Very different from the number line, which you could have fractional and decimal values. Now, the results can be fractions and decimals, of course, if you're dividing, but the term number, n being 1, which we put in, then n being 2. We don't put 1, 1/2, 1/4. We put in 1, 2, 3, and for n. So it says write the first 4 terms. That's easy. We put a 1 in. You get 5 to the 1 minus 1 over 3 to the 1. Then it'll be 5 to the 2 minus 1 over 3 to the 2. And then it'll be 5 to the 3 minus 1 over 3 to the 3rd, and of course 5 to the 4 minus 1 over 3 to the 4th. This one, we start with a 1, so it'll be 2 minus 1. Then we put in a 2, 4 minus 1. Then we put in a 3, 6 minus 1. And then we put in a 4, 8 minus 1. This one's interesting because what you're going to do is you're going to start with 7, okay? And to get 8th, we take 2 minus the previous term, which was a 7. So 2 minus 7 will be -5. Okay? So there's your -5. Then we go for the next one, the third one, we go 2 minus -5. Well, 2 minus -5 is 2 plus 5, which is going to be 3. And then you go 2 minus the previous one, 3. 2 minus 3 is -1. These are called recursion formulas, and used a lot in computer science, used a lot in reality modeling. So let's take something that looks kind of convenient. We have 2, 6, 10, 14, 18. What are we doing each time? We're adding 4. Okay? Since we're adding the same amount each time, we should be able to predict what the 6th, 10th, 20th, and maybe the nth term will be. And you can do that if you pause the video. A sequence is a list of terms where n starts out at 1 and goes 1, 2, 3. An arithmetic sequence is the next term minus the previous term is always the same difference. And I like to say it has a common difference. Okay. And so when we look at a formula, let's look at 2, 5, 8, 11. So for these, we're adding 3, adding 3, adding 3. Now the first term is n equal to 1, and n equal to 2, n equal to 3, n equal to 4. Now what's cool is that if we wanted the fourth term, a of 4, what you're going to do is you're going to start with the first one, 2, and then you're going to get to the fourth one, you're going to add how many 3s? Well, you're going to add 4 minus 1 of those 3s. Now, it's unfortunate 3 and 3 is the same, but you get my idea. Now, let's say we wanted the third term. We're going to start with 2, and then we're going to get to here, you're going to add 2 or 3 minus 1 of the 3s. So the formula works out first term plus number of terms minus 1 times the common difference. Like that. So you could prove that formula, but actually it's pretty logical. When you have that common difference, you're doing n minus 1 common differences added to the very first term. Okay. Well, that's with a common difference. Now, let's look at something like this where we're going from term to term. And this time we're not adding the same, we're multiplying by the same. So here we're going to get what we call a common ratio. Okay, and you can predict all of these. I'll give you some time. You can pause the video and try these. So when we look at a geometric sequence, arithmetic was the common difference. Geometric is a common ratio. So instead of a of n minus a of n plus 1 minus a of n, it's a of n plus 1 divided by a of n. That's a helpful formula. And for this one, let's take 3, 9, 27, 81. Okay, so we're multiplying by 3 each time. Okay, and if we want to know n equal to 1, n equal to 2, n equal to 3, n equal to 4, if we want to know the fourth term, we start with a 3. We start with the first term, 3, and then we're going to multiply by, well, we have 1, 2, 3, 4 minus 1. Excuse me. Way too many 3s here. I'm going to use a different example. Let's try this again. Let's go 2, and then we'll go 6, and then we'll go 18, and then we'll go 24, or let's see, 48. So again, we're multiplying by 3. So you're going to get 2 times, now the ratio that we're going to do is 3, and we're doing a total of 4 minus 1. And then if we were looking at the first 3 terms, we'd go 2 times 3, because that's the common multiple, to the 3 minus 1. And you would get those. So this formula is very connected to the last one that we saw. This is the last term that we're looking for, or the nth term. This is the first term. This is the common ratio. And of course, this is your number of terms that you're looking at. So we're starting to get a bunch of equations here, but you can figure this out. We do the same thing. Find the geometric, here's your arithmetic common difference, right? And then here is your geometric, which is the common ratio of those. And we can determine whether they're a common difference or a common ratio by looking at these. Just list the terms. I always tell students to list the terms and then see if they have a common difference or a common ratio. All right. So with these two formulas together, and for arithmetic, you have D is A of n plus 1 minus A of n, and R for geometric is A of n plus 1 over A of n. Those are going to help you to determine whether they are arithmetic or geometric. And they could be neither as well. So you can go ahead and try these. You're listing terms. You're finding those sequences. Well, we're going to zip on to sums. And sums are a little different. Here's a few more interesting patterns for you to look at. But we're going to zip on down to some problems. And here's one that's kind of neat. If you have the terms k plus 4, 5k plus 4, k plus 20, and it's geometric, find the value of k. So you would agree that the ratio for a geometric sequence is always the same. We're always multiplying by the same r, right? So we could figure out r of this first one, maybe call it r1. That's 5k plus 4 over k plus 4. And then for r2, if we want to call it that, k plus 20 over 5k plus 4. So if you're looking for k, you can kind of see that you could cross multiply and find that value. I'm not going to do that. I'm going to let you do it. I think there's two values there. The sum of the first and third terms of a geometric sequence is 40, while the sum of the second and fourth terms is 96. Find the sixth term. So for geometric, they're doing something kind of interesting. They're listing these. We're trying to find the sixth one. Here is n equal to 1, 2, 3, 4, 5, and 6. It says the sum of the first two. So if this is A, this is going to be A times R, right? And this will be A times R squared, and this will be A times R cubed. The sum of the first and third is 40. So if you take A plus AR squared, it should be 40. And the second and fourth are 96. So AR plus AR cubed should be equal to 96. All right? So AR, what if I took out an R here? I would get A plus AR squared equal to 96. Why is that such a handy thing? Looking at the algebra, can you see how a nice substitution is in order here? We can replace that with 40. So R is going to be 96 over 40. If you divide the top one by 4, you're going to get 24 over 10. And if you take 24 and divide by 2, you'll get 12 over 5. It is 0.24 though, which is kind of convenient. Find the sixth term. Okay. So if the ratio is 0.24, we could, for this first one, take out an A, and you're going to get 1 plus 0.24 squared equal to 40. So you can get A is equal to 40 over 1.1 plus 0.24 squared. That'll give you your A, you know your R, you can find the fifth, and then eventually the sixth term. If you just want the sixth term, you just plug those in to AR to the fifth. So those are some problems. Notice that they're getting a lot more high level. You'll have to try things. There's different ways of solving these, but I kind of like that. Here's a good one. The 40th term of a sequence is 3, and the 79th term is negative 14. Find the term and the common difference. So if it's a common difference, you're probably looking at, with the common difference, you're probably looking at an arithmetic. Right? So let's check this out. A of n equals A plus n minus 1 times d. Now it says the 40th term is 3. So 3, we don't know the first term. We do know it's 40 minus 1, and we don't know the difference. We do know that the 79th term is negative 14. We don't know A, but we know 79 minus 1 times d. So this is going to give you 3 equal to A plus 39d. And this is going to be negative 14 is equal to A plus 78d. Do a little cancellation here. We're going to take the opposite of these so that A minus A is 0, and 78 minus 39, I think, is 39. D is equal to negative 17. So D is negative 17 over 39. And I think we're just trying to find the common difference. If you know the common difference, you can then figure out what the what A is. So if you take this first one, you have 3 is equal to A plus 39 times negative 17 over 39. 79s are going to cancel out. A is going to be 3 plus 17, or A is going to be 20. So not a clean difference, but A is pretty clean, and you would be able to figure those values out. So those are a couple of examples using those formulas. So now you should be able to do that homework pretty well.